So, hi everybody. So today, we'll be discussing about one of the most important concept in an enterprise level, or it may be any kind of an application. So the important concept. So basically, this is used everywhere in day-to-day scenarios. You may, for example, in any app, in any application uses it. It may be Instagram, it may be Facebook, or it may be anything. Basically, this is most like the most important concept that any developer, maybe a backend developer or maybe a front-end developer should understand. So today we'll be discussing about the load balancers. First of all, basically going to the load balancer. Why exactly we need load balancer, right? So first of all, like studying anything or basically like you want to know anything, you should understand why exactly they needed it. What are the disadvantages of not having that one? So first off, before that, before going to the load balancer, the most basic concepts, we'll be going to what is a front end application, what is a back end application, how does a front end application will be communicating with the back end application. So I'll be explaining this whole concept in basically three cases. So first case will be basically a brief introduction of web applications, like how exactly they are communicating and vice versa. So first thing, in any application or web application, right? Everybody knows that there are two ends. One is front end and one is back end. So usually what happens is a front end application will make a request to a back end application. So a front end is an UI, user interface, where actually a client may connect to it. Let's say that you are a client and you are connected to this front end application over here, which I'm showing in this image. And if you do any kind of an operation from that application, it will make an HTTP request or HTTPS protocol request to the backend application. So we'll be not deep diving into what is HTTPS. We'll be basically seeing that one in the later videos. But our main goal, our main agenda is for this. This video is like for load balancer. So a front end application make a request to a backend application. The backend application is basically an API. You know, any backend applications or anything which is actually serving you can be an API. What is API? API is basically an application programming interface. You know, APIs are something which actually gives you a data. So when a front-end application makes an HTTP request to a backend application, in return of a response, it will give a written data. So that data will be visible in your, you know, in an application in the front end. Which can with some of the styling, CSS done in a very beautiful way. You can see that data. So this is a briefly about the front end and back end. So but why exactly we need everything is working fine, right? Now front end is sending the request to the back end and back end is giving a response and everything is working fine. But why exactly we need the load balancer? The load balancer. That is a question that we need to discuss right now. So this is the first case, you make a request, you get a response. So everything is working fine. But let's say let's say for example, let's take you have built an e-commerce application. So everything was working fine, every day you have users, up to every day 10 users are requesting every, basically every minute 10 users are requesting your application and your application is working fine and everything. So what you thought, like, basically, you want to improve the business. So what exactly you made is, you thought to give an offer. So in front, let's say that there's a some festival, Diwali or some kind of festival, and you thought to give an offer. So what happens in exactly when you give an offer, right? So that will be a very second case. What as soon as you give offer, right? So every people are very greedy to buy some new things with some kind of offer. So what exactly happens is, if you have before in the previous scenario, let's say you're getting 10 requests per minute, then now the client request may increase. Per minute you may get some 20 requests, 100 requests, or 200 requests, or 300 requests. So what exactly will happen in this scenario, in the second case, is when clients are making a request, like more number of requests which is from front end, it is reaching to the back end application, right? So there is only one back end server which is actually having an application here. So when I say a back end application or any kind of a code, basically in terms, you will definitely should deploy in a server. So when you deploy your code in a server, code basically your code needs some kind of resources to run, right? So for example, CPU, for example, RAM. So whatever your code, basically it's running, it's needs some kind of resources. So CPU. So let's say that one request is coming. You need some kind of resources from the RAM to fetch the data from the database, some kind of an operations to be done from the database. So what exactly happens is when you have a single server and every request comes to this particular thing, the processing time at that server may reduce because the request from the front end applications are more, but the back end application is unable to process it. And due to that, what exactly happens is you may not be able to serve every request to the clients. So due to this, basically what happens is the client may get disappointed even if you give an offer, right? So the client may get disappointed, basically you're unable to satisfy the needs of the client. So in this scenario, right? So taking how can we actually solve this problem? Basically I have one backend application. So how can exactly I solve this problem so that every client who is making a request can actually get the response in a real time, or in as soon as they don't there's like there should not be any downtime, right? So how exactly can we solve this kind of a problem, basically? So we'll be not going into like what is a database and how this application is communicating. So the main agenda is load balancer. So let's move on to the third case where exactly we'll be introducing a load balancer. So this is a third case, your clients are, in second case, your clients are unable to properly, get a response on the backend server. So what exactly an organization did is, or any kind of so what you did is as an e-commerce owner or a CEO, what you exactly did is you try to introduce a something in between a front-end application and a back-end application. So what exactly will happen when you introduce a load balancer here? So first of all, I'll when you listen the word itself, right? The load balancer. In by listening itself, you can tell that there's load. Basically it can handle load. So load is nothing but in our case, in terms of an application, right? So load is nothing but a request. Basically any request, just sending a request contains some data. It may contain some payload. It may contain some the JSON data which is sending from the front end to should be processed by the backend. So request you can basically term a load as a request, request to the backend server. So now what exactly happens is in if you introduce a load balancer here in between. Now if you observe a backend, right? Previously in this case we had only one backend application which is actually communicating with this database and getting the data and it's doing things. Now we exactly have three backend servers. I just did not had a database diagram, but in by end, you can have this database here. These three backend services will be communicating with the database. So and here these three servers, basically these three servers will be running the same code. You can call it as an instance. Basically you can term it as an instance. Like because you have multiple basically you have multiple servers which is running the same code. So you have one application, you have instances of three servers. So you can call it as instances in terms of understanding purpose. So here now you have three backend servers, one front-end applications, and clients are making requests. Now your front-end application will not make a direct call or a direct request to your backend APIs. Basically, right, in our the most in the real world scenarios, now basically backend should be the most secured way. Backend should be the most secured because all your business logic, right? So for whatever you need for an application is written at the back end. Front end application is just you send a request for the data. The data is stored at the back end. So one more important point to note down here is, basically you should never expose your backend servers or the backend APIs to the clients. You should never expose. So the one important major factor, with the help of load balancer will be solving is your client, when you send a request, will not directly send a request to your backend server. He'll be sending a request to your load balancer. So in this case, the request go to the load balancer. Then based on the request, based on the request, the load balancer will decide to which server the request should be redirected. Now let's say that again you give an offer for Diwali. Now let's say that you are getting 1,000 requests per minute. Now in this case you have a load balancer over here, and you'll be able to manage the traffic between different servers here, because you have multiple backend servers. Then you can return the response from there. So you can manage and everything is going fine. So here is just, so this is the most important point. Basically why exactly we need load balancer. So the basic, the simple definition, if you want to have a load balancer, is basically for distribution of a traffic. You can you need to distribute the traffic different between multiple backend services and make sure that your application is reliable to the client and highly available. So what is going to exactly happen over here is, basically, let's say that now B1 server has been failed. Your load balancer can redirect the request to the B2 server. So there is no single point of failure here. Let's say that now, if you have only one backend application in the case, first case and second case, if a backend application goes down, right, to any kind of a point, it's called a single point failure. So when you introduce a load balancer, you'll be not having a single point failure. That is one advantage. And one more thing is, with help of a load balancer, right, you'll be doing a horizontal scaling at the backend thing at the server side. So there is two types of scaling, basically two types of scaling. One thing is horizontal scaling and another is vertical scaling. So what is like difference between the horizontal scaling and the vertical scaling is basically means is, let's first speak about vertical scaling. So in vertical scaling scenario, what happens is, let's say that you have one backend application here, and let's say that it is having 20 GB of RAM and 500 to 600 GB of memory, like some for example case, like for example. So when a request comes, or you feel that okay, this is the process, the performance of this is reducing, you can do a vertical scaling. Basically from 20 GB of RAM, you can increase to 30 GB RAM or 40 GB RAM. So basically you're scaling a particular server and you're increasing the resources of it. So basically vertical scaling means you'll be just increasing the resources on the top of that server. So but the point, there's one drawback with the this vertical scaling is, basically you can increase, but there is one end point. You can't just keep on increasing the resources come from 30 GB to 40, 50 to 100, 100 to 100, because you'll be need a supercomputer. That's it's not a supercomputer, and it even costs more, basically verticals. But it depends on your scenarios, basically to which kind of scaling you need to use. You need to use the vertical scaling or horizontal scaling. It basically depends upon a scenario. For example, let's say that now my application, as a person of now let's say that you have built an e-commerce application, and how many clients will be requesting your application. So if you know these are the X number of requests that my application needs, then definitely it's fine to go with the vertical scaling, because you know that there will be no more hectic traffic on your packet servers. But if you don't have any idea like how exactly the request may change, or how many number of requests can come, then what exactly will happen is you can't actually go with the vertical scaling. You need to choose something called horizontal scaling. So this is B1. You can see the servers, right? The B1, B2, B3. These are called horizontal scaling. Basically, in horizontal scaling, what exactly it defines is, the main important point is in horizontal scaling is, you'll be having multiple instances of an application running in different servers. Now, let's say B1 is running the same application, B2 is running the same application, B3 is running the same application. So if for example, let's say you have 8 GB RAM for three servers, so it will be 8 into 3, 24 GB. So your request will get divided into these servers, and the performance, the processing of that request, everything will increase. So the best case scenario where basically you don't know your business requirement, or you don't know what exactly you need, then you can definitely go with the horizontal scaling. But if you know like the exact business requirement and everything, now basically you can move with the vertical scaling. So I think I hope so. Just like a brief understanding of load balancer. Right? So let's see now what exactly the advantages, advantages of load balancer are. So some five, some six or seven, advantages. Main advantages actually named out here. So first one is improved scalability. So what they're telling is load balancers can enable horizontal scaling by distributing incoming traffic among multiple server resources. This allowed you handle users, more users and traffic by simply adding additional servers. So as just before I told you, so load balancers, basically they're enabling the horizontal scaling. It can enable the horizontal scaling, and it will make sure that the users can be redirected to the multiple backend servers, and they can actually perform, basically the required operations that can be performed, and basically it can, increase, the what you call like the scalability. Scalability is nothing but, basically increasing your backend instances. Scalability is something that, increasing your backend instances to make sure that you'll provide a high availability. So basically the next point is, high availability. So what exactly high availability states that, load balancers can detect server failure. So one of the most important point here also is, load balancer will be actually doing a health check for all these backend services. Let's say that B1 is failed, B1 got down. So load balancer will get to know that B1 got down. So when a person from the front end makes a request, it will make sure that the request will not go to the backend B1. It will redirect request to B2 and B3, because it knows that, like B1 is very, unhealthy, so I'm not going to send request. So basically these are the more important concepts. So basically in this video we'll be seeing what is the basic understanding. So we'll be not deep diving into this whole concept. So there are many things, there are like algorithms, to redirect the traffic between the backend services. There are different kind of routing methods, basically it will be used. There are different kind of load balancers. A load balancer, now let's say that load balancer may work at layer 4, which is at network layer, and there are some other load balancers which can work at layer 7, which can actually, HTTPS, or called application layer. So it can actually do a validation, it can do a request validation for what you call transformation of the request. And there's another load balancers, basically it can do a global traffic. So there are different types of load balancers, basically. But the core point of any kind of a load balancer is, so it makes sure that it redirect the traffic, to the backend servers. And the third point is enhanced performance. So by distributing traffic evenly, load balancers prevent any single server from being bottlenecked. So what exactly it is telling is, it distributes the traffic between different servers. So the user may not be only dependent on a single server. If one server goes down, then definitely, right, there is one more server which will actually serve your request. So this is what this things. And fault tolerance. Load balancers can be configured with multiple algorithms to route traffic based on various criteria such as least connections, round robin, least response time. So as I told you, right, so there are different kind of algorithms. Basically one scenario is like, let's say now A is a person who will be connected to the A backend server. Now A is a person will be connected to the A backend server. Now when same person sends a request, right, you need to be redirected to the same backend server, because if he send a request to the load balancer and load balancer redirect to the second backend B server, then there are some kind of an operations, right? So A user performed, so which will not be reflected in this or the database. Basically the most important thing you need to consider here when you use a load balancer is the database, the consistency of the database. Basically there is, we're not going to go deep into it, but I'll be just explaining a brief what is a consistency here. So basically in terms of databases, right, we have four important properties. Acid properties, I think, atomicity, consistency, durability. So consistency, what does it state is a data should be a consistent between two different systems, basically, right. Now B1 is making some changes here and B2 is actually making some changes here. So you don't know, right, which client can be connected to which database. So you may fetch data from B2, or A user can connect to B2 sometimes, or B1 sometimes. So you may fetch the data from the database. So the data should be a common data. When you fetch from B1 server, it should not be a different data. When you fetch from B2 server, it should not be different data. So the consistency of a database should be maintained when you're using a load balancer. So that is one thing. And just like that, you can actually have multiple algorithms. That's thing. And the one of them again, the SSL termination. So SSL stands for secure socket layer. So what exactly SSL do is, basically when you are making a connection, right, it may be any connection nowadays. It is in the form of HTTPS. It is a secured communication. The data between a client and data between server are encrypted. Am I right? So if you need that encryption, for example, why you need SSL is SSL is something, SSL certificate is something, basically it tells you that, let's say that you're requesting my server and you'll tell that I am having the certificate. You can actually access my server. You can access my server without kind of any problem. So I'm not a hacker, or I'm not anything. So you're claiming that with an SSL certificate, basically you're claiming that I'm a secured person. Your secured application. So you have a secure application. You can actually do it. So what exactly happens is load balancers. No, I can't say that every load balancer can do an SSL termination, but some load balancers, basically which works at layer 7 can actually do SSL termination. So what happens is whenever you make a request right from front end to back end application, basically before load balancers, when you observe right, though when a request go to the backend server, the data will be encrypted, right? So usually, so the data should be decrypted. So backend server is to perform that kind of task. So what later on, what exactly happened was is you are doing SSL termination at load balancer itself. So basically, you send an HTTPS request to a load balancer. At load balancer, if you select an option called SSL termination, it will decrypt your data, and the data between the load balancer and your backend server will basically be pure data. Basically, it will not. There is no any cipher data. It will be in a form of plain text. The load balancer is communicating with the backend. So a backend thing, no need to do, no need to have again any separate code for basically decrypting this data or some other kind of stuff over there. So you can actually take the data and return that response to this load balancer, and the load balancer at the end of the day will return the response to the client. So this is brief of SSL termination. So we'll be going now, basically we'll be going very deep dive into each and everything in the coming up video. So this is just an introduction. So and one more point is traffic management. So load balancers can route specific types of traffic to dedicated server or resources. For example, you can direct API requests to one set of servers and web traffic to another. So even this is also same thing basically. You can actually have it depends upon the kind of an algorithm, kind of a setting which you're using. So I'll be doing practical sessions on different kind of load balancers which you're actually having. So purely I'll be doing based on Azure. So in Azure we have four types of load balancers. One is a layer 4 load balancer, one is a layer 7 load balancer, which is called application gateway, and another is Azure front door, which also works at layer 7, but it is a global load balancer. And one more thing is traffic manager. So traffic manager is something which works at the DNS level. So I'll be basically doing everything in a practical session. So the last point is security. So the load balancers can help mitigate DDoS attacks by distributing the attack traffic across multiple servers, making it more challenging for attackers to overrun the single server. So, DDoS attack is basically something, sending a request from a single client. Every client has an IP address. So, if we talk in terms of an IP address, right? So, in terms of IP address, basically every client, when they make a request, you'll definitely be having a public IP address, right? So, what exactly load balance can do is it when you make a request to a particular server in the same time, very fastly, what exactly happens is it can't process it, so the server can get down. So this is the very most dangerous attack. Like DDoS attacks are distributed attack is very dangerous on a DNS service of attack. So these attacks are very dangerous. So you can actually reduce that kind of attacks when you by introducing the load balancer. You can actually let's say that now the same client is making five requests to this load balancer at a time. So you can make sure that okay, this client is this from this IP I'm getting this many clients, so I need to block this IP. So you can make some rules at load balancer so to mitigate that kind of attacks. So the same thing you can actually do with rate limiting. There's a separate concept called rate limiting. So you can limit the number of requests which is coming from the client. So we'll be not going into that and all stuff. So yeah, so this is like a brief overview or any kind of a thing. So load balancers. So we'll be next video, right? So we'll be discussing more depth, in terms of maybe in terms of concept wise. Basically I'll be explaining the load balancer, what are the different types of load balancer in Azure. So this is just basic concept of load balancer. I hope It's like good, just went on with flow. So yeah, thank you everybody. So we'll see you next video.